first thing is, if you check today, Edmodo wasn't working when I tried bringing it up anyway. I don't know if it is going to be up by 9. I will try to get this presentation up whenever it's back up and running. Okay, so let's review. This is basic exponent stuff, where we take the base, however many times it's multiplied times itself, that's the value of the exponent, or the number of the exponent. When we multiply bases that are the same, we add the exponents. Okay, so if this was 3 and that was 2, 3 plus 2 is 5, and that would be your answer. Multiplying, and actually someone on the test that I graded earlier today multiplied when they were distributing through the variables. They multiplied their exponents. When you're multiplying bases, you add exponents. We've also had the negative exponent. Had a couple of people apply the exponent, the negative exponent, to the value of the number instead of just dropping it across the fraction bar. Okay. Also had some people that I think the value you plugged in was -3 on your test in parentheses, and then it was to the 0th power, and a number of you wrote -1. Catch what I'm saying? You had this, and you wrote -1. But anything to the 0th power is always 1, no matter what. Doesn't matter if it's a negative or a positive. Ethan?
If there's a negative on the outside, it's a -1, right?
Then that's different. If there was a negative in front of this, then you apply the exponent of 0 to that part. That gives you 1. Then you bring your negative across. Okay. All right. Then we have, this is division. If you have x to the m over x to the n, then when you move that n up, you subtract it from the existing one. Okay, these are all rules that we have covered already. These are just the different forms. Okay, power rule. All right, so this is new. This is the, I call it product, but it's power rule. Notice that you have x to the mth power in parentheses, then to another exponent. Okay? Since we're taking an exponent to another exponent, then you do multiply those. That's different than this situation when you're multiplying bases. Here we're multiplying bases that are the same, so we added the exponents. But on this, you're taking an exponential to a power. And we'll look at the actual process here in just a minute. That you just, when you have a number or value to the power, like this here. A to the 5th to the 2nd power. Very simple. Since you're taking an exponential to a power, it's just a to the 10th. Just multiplying the two exponents. When you're taking an exponential to the power, okay, you're squaring an exponential. Why would that work? Before you ask a question. Doesn't this mean a to the 5th times a to the 5th? Isn't that a to the 5th squared?
Yeah.
Okay, and so then we're multiplying bases that are the same. So when we multiply bases the same, we add the exponent, so it gives us 10. But rather than going to that longer process, we just say, okay, we're going to multiply those two. Kelly, what's your question?
So, like at the top, it'd just be, oh, it even, okay, I see. I didn't write it.
Okay. M to the -2nd to the 4th power. Quentin.
M2.
M what?
2.
M2. Why 2?
Because -2 plus 4 is 2.
But we're multiplying.
-8.
There we go. -8.
Well, can you put 1m8, like 1? No, you have to add under m. Yeah.
1. You could put a 1 up front. Okay, so then, right. So the question is, couldn't you write that as 1 over m to the 8th? Yes. That's how you'd get rid of the negative exponent on that.
Maybe wrong or right.
Either way. Be accepted.
Your lettering is messed up.
And
On
C
the side.
should be B and the
It's
and the
nothing
B is
A,
probably
C.
C.
You just leave the
That's a
C.
good point.
It's nothing A, C.
Don't we still have one more
Oh,
problem?
maybe.
It's F.
I wonder.
Maybe there's all
don't-
these different ones in here. You might have just
That's right. I chose
You
A,
just
C, and F
chose
rather than doing each one of them out of the book.
Oh.
Okay, so on F you have mk to the second power. Kaylee Logue, what would that be?
MK. Well, M2K.
Very good. M2K. 2K. It'll depend on what the value for K is. Now we're going to just blow this thing up entirely. Gonna throw it at you. Does the coefficient of 3 at the start of this problem have an exponent on it?
No. No. Yes.
What is it?
One.
It's 1. So it does. And we are going to apply this to the coefficient as well. Because this whole thing is to the negative second power. The nice thing about the product rule or the power theorem here is that you just simply multiply this times each exponent inside, no matter where it's at. So 3 to the first would become 3 to the negative second. Excuse me. Then x to the negative second would be x to the negative second times negative 2 is
X
4. Y to the negative 10th over z to the negative 8.
Oh, you times the.
You're just multiplying the exponents on each thing.
Oh, okay.
There would need to be some directions given to you about how to write your answer at this point. You more than likely would want to kind of clean up this because this does have the negative exponent on it. We can drop it down, but I'm going to leave everything else the same since there isn't any instructions about putting everything as positive or negatives. So this 3 to the negative second is going to drop to the bottom to become 3 to the second, which becomes 9z to the negative 8.
I thought you always wanted your whatever you want to call those things, numbers.
Coefficients?
Yeah, at the top.
We've left them at the top because they haven't had negative exponents on them.
And you have to change them back?
No, I'm not saying that. It's just better if you get rid of the negative exponent on them.
So you don't have to do that?
We'll see what the directions. I can't remember how they want you to do that. We can work with it. Yes.
It says right on today's you have to be in your numerator.
So on that problem,
Yeah.
or on the
On the
homework for today.
homework.
Okay.
So we're gonna do that on homework then?
Well, it says write everything in the numerator. So then we could write it as 9 to the negative first, x to the fourth, y to the negative 10th, and then this would become z to the 8th. And then you'd have everything in the numerator.
Or, my question was like, instead of an X, if you had like a Z, could you do the canceling cross?
Yes, you'd still want to combine
How'd you get 9?
things.
Because
3
it said
squared.
3 squared.
3 times 3.
squared.
So what, could we leave it as 3 to the negative second, or do you want it as 9?
I don't know. I would get rid of the negative exponent. But then if it says write everything in a numerator, then you move back up. I think it's going to work out for you. Don't get caught up in, am I supposed to do it a certain way? Just get it worked down. And I do want it worked out. And to apply the squared, you have to move it down. Because we can't square a negative. So you have to move it down just to be able to get to the 9. So you do need to apply that. So I guess you just work it out. And then if there's some instructions about where to put it, then you move it later.
There's no coefficients in the homework file.
Okay, so that'll make it easier. And this one's going to kind of work out that way. So our exponent on 2 is 0. 0 times 15 is 0. So that's 2 to the 0th, which has a value of 1. x to the negative second to the 15th would be x to the negative 30th, y to the 60th over z to the 15th. If it said write them as all positive exponents, you drop the x down. If it said write them all as positive or the negative exponents, then you move your y down, move your z up. If it said move them in the numerator, move them all up. Denominator, move them all down. Yes?
What did you do with the 2 to the 0th power? Like, how did you work that out?
Okay, 2 to the 0th, we take times 15 is 2 to the 0th. Oh, is 2 to the 0th time, so we take that times 15 is 2 to the 0th, which is 1. And so I just left off the 1, but you there you can put the 1 there if you wanted. Any other questions on that? It's the power theorem. We have an exponential to an exponent. Just multiply the exponents. One more little piece to this, it looks like. Use 3 unimultipliers to convert cubic feet to cubic inches. We have 180 feet cubed over 1, and we want to convert that to inches, so we have 1 foot is 12 inches. So how many times are we going to have to do that?
2 more times.
2 more times for a total of 3. And that cancels the feet, the cubic dimensions, and then 180 times 12 cubed inches cubed. So when you see cubic feet, you cube the unimultiplier.
I love those.
They're just easy. Yeah, they're just easy.
Once you know your conversions of what.
Yeah, I guess.
Yeah.
We've had them on that.
You don't even have to, if you know what your conversions are, you don't have to think about it much because feet's here, so I just need to put the feet here and then
Yeah.
go from there. Use 6 unimultipliers to convert 800 cubic centimeters to cubic feet. Oh boy, 800 cubic centimeters, so that's centimeters cubed over 1. What do I have to change centimeters to get the feet?
2.54.
Into inches. So that 2.54 inches goes on top, doesn't it? Inches to I didn't do it right. 1 inch to 2.54 centimeters. Whoa. Times 1 inch, 2.54. You know what I'm going to do? I'm going to shortcut this.
Can we do that homework?
And then times, we need to change our inches now to feet. So there's 12 inches to 1 foot, and we would need to do that 3 times. Oh, maybe there's a connection between the power theorem and this lesson. This part of it is when we distribute through now, or take our power theorem, 1 to the 3rd is still going to be 1. So let me go ahead and show you the arithmetic, even though we wouldn't normally do this. So we have 800 centimeters cubed, then that's going to be times inches cubed over 2.54 cubed centimeters cubed times the 1 to the 3rd is still 1. I'll go ahead and write that in there. 1 feet cubed, because the foot has an exponent of 1 on it. 12 cubed inches cubed. And so that's what allows us to get rid of this and this. And so your answer is 800 over 2.54 cubed times 12 cubed feet, oops, not equals feet, but feet cubed. Good one. You guys,
Do like the
You do that way.
if you wanted to do this, that's fine.
I'll probably do it.
Yeah, it's fine too.
Oh.
So it doesn't matter which way.
Nope, your choice. I've never done it that way before, till today.
Do you like it that way better?
I do,
Can we do like the cubed on homework?
as long as you do it correctly. Yeah.
We have to do
Just
this
make
part.
sure you're, because of our power theorem we learned today, you realize that this exponent is being applied to each dimension and to the number.
Oh, yeah.
That's why they threw this in with that lesson. Yes,
So that's not in the lesson.
you won't see it like this, I don't
So
think.
that wouldn't be the answer?
Yeah, this is the answer.
I know, but like if you just write it like that.
Whether you do it the way we've been doing it, or whether I do it that way, that's your answer. You're gonna get it simplified to that.
Always the same.
Gotta go into Wichita one way, going to Wichita straight ahead on 47, or going to the highway 400 and going.
You're doing it smarter than the other one.
Just depends on what you wanna do. If you wanna go through Parsons to see your brother at work, then you'd take 400. Huh? Huh?
I don't know what you want.
Where's he work?
I don't know how to say it.
Can you spell it?
Something like that, yeah.
That's where my grandpa works.
Where?
Yeah, my grandpa said that he works with you.
Where?
Because he was talking about how smart you were.
He's like, is there a girl in UConn who's really smart? And he's like, yes.
Ducama?
He's like, I go to work there.
Loeb!
What?
Kaylee Loeb.
Yes.
Say it to me.
Do common.
Ducommun.
D-U-C-O-M-M.
What do they do?
Build airplanes.
Yeah,
Build
they-
airplanes.
They build airplanes
Yeah.
in Parsons. Where at? Like what part of town?
It's over by like, I think it's over by like Twin Square. I'm not sure.
I know they have a place in Denver.
My Dwayne's photo?
Well, Daddy works for.
This is still recording. We're talking about airplanes now.
Ah. Alright, your assignment. I know we have stuff going on tonight.
We have the
Oh yeah. Can we not do it for 20 minutes?
We go straight from practice. The girls have no time.
Guys. Stop it. You're the one causing it. That's so going.
Hey, morning.
Maybe could have been shorter, but it's not. So you do have early morning seminar tomorrow. You also have 20 minutes class, so each bit of talking that takes a minute longer just makes it that much less time to be able to work here, and then you're going to have to work after the dance, Miss Michael, and then you're going to be complaining, crying, and the parents are going to be mad that you have to stay up late.
Might want to click stop.
Mr. Clevenger, can I go to the bathroom?
Basketball.